Welcome, 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 ladies and gentlemen. I'm here today with Miss Kimberly Dillon, who is going to be giving us a technical presentation today on her journey from Long Beach Unified School District, graduating from Poly High School, one of those jackrabbits, and her journey to how she got now to the Port of Long Beach. And so she did graduate back in 2013 from Cal State Long Beach with a geology degree. And she's now currently working as an environmentalist assistant associate. Did I say that correctly?
It's a long one, but environmental specialist associate.
There you go, from the Port of Long Beach. So Miss Dillon, if you are ready, the stage is yours.
Great. Hello, everybody, and thank you, Mr. Fisher, for inviting me over to give this presentation. Let's see if I can share my screen.
Do you have access to do so? How about that? You are now muted. I don't know if
Thanks everybody for bearing with me. Here we go, share. All right, thumbs up, can you see it?
Yep, perfect.
Okay, all right. So thanks again, Mr. Fisher, for inviting me, and thanks for having me. As he said, I went to Long Beach Poly, I attended CIC, and went to Long Beach State, and I am a geologist. Small disclosure that this isn't an official presentation by the Port of Long Beach, but I am an employee there. I am an environmental specialist associate at the Port, and as my official title, I apologize if you guys hear background noise. I live under the Long Beach flight path, Long Beach Airport flight path. Today we will cover, hold on one second. Today I'll go over how I got into geology, what a geology degree entails, what types of jobs I've had, and highlight one of my current projects. I'll also briefly describe other careers geologists hold and can then answer any questions the group may have. I attended Long Beach Poly within the CIC program, and I happened to see a display case for a geology class as an elective and signed up for it my junior year in high school. The class was a full-blown hands-on lab class. Our teacher would make fake like soil columns and rock columns that we would have to excavate and dig plastic fossils out and date them based on a geologic time scale. He had some amazing labs where he baked a bunch of brownie cakes and filled them with like sunflower seeds, peanuts, M&Ms, and we had to mine these resources out using toothpicks and straws. Nothing was ever the same in the class, and everything kept us engaged. And one of the best things that he did, similar to Mr. Fisher, is have several people in the industry come to give presentations. One of these presenters was at the time, the chair of undergraduate admissions for the geology department at Long Beach State. So I was sold. I was sold that I was going to major in geology, and my high school teacher recommended me to apply for a paid summer internship through Cal State Long Beach, and I earned a spot for 2 summers within this internship. I was later accepted into the geology department and pursued my geology degree for 4.5 years. A geology degree starts out very similar to most STEM disciplines. You start with chemistry, your math, your physics, and then you go into your core major classes. But one of the biggest differences in my mind between a geology degree and some other STEM disciplines is that it is very field trip heavy. So you are going out on field trips for every single class, and you spend like a weekend away camping. So it's because it starts out very similar to STEM degrees, you meet a lot of people that are engineers, and you meet people who are biologists or going on to study stats. I actually met one of Mr. Fisher's previous students, Victor, in a calculus math class over the summer, and we ended up having physics together in the fall. And he was the one that recruited me to bring to do this presentation for Cabrillo. So college is one of the first networking opportunities that you guys will have, and I highly encourage developing that skill. Moving on from your basic geology courses or any course that you're doing, any major that you're doing, I highly encourage seeking out work experience within your department. Oftentimes professors will have projects that you can work on with them. And I actually got to do a lot of this during college. Throughout college, I was able to work with one of the professors who was my supervisor during my high school internship at Cal State Long Beach. I assisted graduate students by teaching them field techniques I knew, like water sampling with a Van Doren, sediment core sampling and analysis. Like I said, huge advocate for students reaching out to teachers and professors to see if they can volunteer in the lab. Sometimes they may have paid positions like mine, depending on their grant status that they've been awarded. I worked with this professor and her graduate students for about 2 years, and then applied for a college internship at the Port of Long Beach, which showed me more career options aside from just research. I started a college internship with the Port of Long Beach my junior year of college. I actually worked as an intern for my current supervisor. And through this internship, I explored the environmental career sector. I worked with the port's water quality team and to perform stormwater inspections. I worked frequently with the air quality team to create databases of vessels with cleaner engines that would qualify for some of the port's incentive programs to bring these cleaner vessels to the Port of Long Beach. Once I completed my degree, I basically had two options in front of me: either apply and attend grad school or start working. I chose to forego a graduate school degree, basically because working was really great and I could always go back to school if I wanted to. I landed a job as a project manager at a small soil gas laboratory and drilling company in Carlsbad. I'll briefly use this image to talk to you about and describe what soil gas is and the role it plays in the environmental industry. So soil gas is the vapor phase of a chemical or air. You could think of it as air or gas that fills soil pore spaces. Samples are collected and analyzed for chemicals related to the release of hazardous substances. Geologists and engineers use this data to determine human health risks for occupants of buildings that may be affected. In this image, particularly, a release from an AST, or an above ground storage tank, occurred, and it released contamination referred to as DNAPL sometimes. That's dense non-aqueous phase liquid. Typically, DNAPLs are associated with dry cleaner sites. The chemicals that dry cleaners used to use are notoriously hazardous and bad for human health. So the above ground storage tank leaked contamination down. It got into the groundwater and into this area, which is called above the groundwater table, which is called the unsaturated zone. So you have two sources of contamination. You probably have dirty soils that are contaminated by DNAPL, and then you have soil gas that is off gassing from the contamination in the groundwater into this unsaturated zone. And that gas could leak into or infiltrate through a compromised building foundation and into the commercial building that the AST is associated with. It can migrate down gradient and go into homes or other industrial type buildings. Gas stations also have the same problem. They still typically have an underground storage tank that leaks LNAPL, which is light non-aqueous phase liquid. So a lot of the petroleum compounds are lighter than water, and they actually will float above at the top of the groundwater table. So my job was like a sub-consultant to a primary environmental consultant who is typically a geologist or an engineer. I was responsible for booking field crews and advising on different analytical methods that the consultant could use to analyze the soil gas samples. It was the primary consultant's job, or the geologist or engineer's job, to interpret the data and determine how to mitigate any risks involved. After almost 4 years at this job, it was time to move on, and I accepted a position back at the Port of Long Beach, but as a project manager instead of an intern. And so this is my current job. And before we go into the particulars about that, I kind of want to give a quick snapshot of what the Port of Long Beach does. I'm sure several of you have heard of it. We have a fancy new bridge now. You guys are close by. The Port of Long Beach is a large industrial complex that has been in operation since 1911 and consists of terminals, wharfs, and other commercial businesses. The Port of Long Beach supports an estimated 1 in 5 jobs in Long Beach. Given that the port has been in operation since 1911, it has a long history of commercial and industrial land uses, such as oil field operations, so drilling, refining, storing, shipyards where they would actually build the ships, variety of mechanic shops, and even historic military uses. All of these industries involve using hazardous materials, and as such, there is a potential for contamination release into the environment, and that's why I'm involved, and that's why geologists work here. My job at the port is to investigate project areas ahead of earth-moving activities, like constructing roads, building rail yards, demolishing buildings or building buildings. So my job is to assess those areas ahead of construction to determine if any hazardous materials or substances are present in the subsurface, so that the engineers in charge of designing the project are fully informed and can make decisions that impact the health and safety of construction crews, project schedules, and project budget. In the next slide, I'll highlight my current project, the Pier B On-Dock Rail Support Facility Program. The Pier B On-Dock Rail Support Facility Program, or the Pier B program for short, is the next major capital improvements program after the completion of the Gerald Desmond Bridge replacement project. The goal of the Pier B program is to build a bigger rail yard so that we can build longer trains and decrease cargo leaving by trucks. This will be accomplished by adding new tracks, building a 93,000-foot support yard, and realigning existing roads in the port to accommodate these tracks. So as you can see from this image, the Pier B rail yard runs through the northern part of the port. This is the LA River. I think Cabrillo is up here somewhere. You guys are, I believe, east of the river. I could be wrong. You guys could correct me later. So it's a 15-year program. I think we're only on year 2 or 3 right now. This 93,000-foot rail yard will be right here. We're going to have several tracks. And it's an $870 million approved budget. So it's a beast of a project. So my role at the port, and in conjunction with my group, is to provide technical support to our engineers. So we serve as technical consultants for the program for matters regarding hazmat and waste. So we give them the data. We also advise and consult the engineers on remediation alternatives and hazmat and waste. So that's more of, okay, here's your problem. These are some solutions we could talk about. So my group has close to 200 acres of land to assess ahead of the start of construction for this program. We've created a systematic approach to our investigation that starts with a phase 1 environmental site assessment. This is an industry-wide standard report produced to give the property owner, like the Port of Long Beach, or the city of Long Beach technically, background information about a certain property and identifies what are called recognized environmental concerns, or RECs. RECs are defined as the presence or likely presence of any hazardous substances or petroleum products in, on, or at the property. You could kind of think of a phase 1 ESA as an environmental history report of a site. Concurrently with the phase 1 ESA, our consultant also initiates a soil gas survey, like my first job. The soil gas survey, however, is more of a, we use it more as a screening tool instead of using it to assess human health risk. Soil gas is great in that it can help us determine any hot spots in the subsurface. So we grid a site and collect soil gas samples every 50 feet. Once we have the data back, we can then work with our consultant and determine if we need to investigate further by collecting a soil and groundwater samples, or if we have enough information and we could close out the site. Our final task is to produce what is called an engineer's estimate. That gives the program engineer a ballpark idea of how much it will cost to remediate the site. So that's my job, and those what my career has been so far. There's so much more that I can do just at the Port of Long Beach. I wanted to kind of also show you guys, just in case you weren't into environmental geology or environmental engineering, that there are so many other career options that can start in geology. So you could work in hydrogeology, which in my personal opinion, I think is one of the best careers that you can choose right now. Groundwater and water resources are going to be the next major thing that we are going to look at. Of course, living in California, we're always talking about being in a drought. So if you could be a hydrogeologist and help manage aquifers for drinking water, that's a solid career. You could go into geotechnical engineering or geotechnical geology, which those geologists are assessing how stable the ground is when you're building. You could go into climate change. You could go into stormwater. You could study earthquakes. You could study that as a geologist. You could study that as an engineer. You do something really cool. You could study volcanoes in Hawaii or Oregon. You become a mining consultant, which we don't really talk about in California that much, but it's a larger industry across the country. Of course, petroleum geology will probably always be around, especially in our location. We have a pretty large oil field down here in Southern California, especially Long Beach and Wilmington. And then another type of job, you could work for a regulatory agency. And those are the people that are studying the effects of contamination or other things on human health. They're the ones that set limits. They really hold a lot of information, and they help us govern the environmental industry. And that's about it for me. I would love to keep talking and love to get feedback or questions that you guys have. Happy to answer all your questions.
I'll be honest, I don't know if it's because the kids are getting prepared for finals and stuff like that. This is the first time we haven't had questions. So I do apologize for that. Guys, are there any questions that any of you have for Miss Dillon? I know for me, what is, when you talk about your role as a geologist, and what you had to go through, you said there were a lot of field trips that you had to go to, hands-on experiments type stuff. Now, is geology, you talked about that it's a mixture of like chemistry, math, and physics, that all of it kind of comes into play. Which one is geology more heavy in though? If you had to give your input, like it's more on chemistry, it's more on physics, or it's more on math, or is it a good equal partition while you're taking your classes?
I think it's a good like spread across the three, which is nice. It means that you don't have to be this stellar calculus performer or a stellar chemist or a whiz at physics. Like you can be good at them and understand them and be able to be very successful in your classes. For me personally, when I look back, I always think of physics, but I don't think like F equals MA. Like I don't think about that often. But a lot of things, a lot of tectonic processes, structure related geological structures, or you have to have an idea, you have to be able to wrap your head around the physics of that, of, okay, if I push something together like this, what is it going to look like later? Yeah. If I'm going to rip something apart, what is that going to look like?
Kind of the compression and tension of system.
Yeah, gotcha. Exactly. And that goes, like, what's really cool about geology is those principles go all the way from mountain building and this like that scale to something that you can see under a microscope. So yeah, so one of the other classes that you take, they'll take a rock and they'll deli slice it almost. It's not the mechanics of how these are made, but imagine slicing a rock paper thin that you could see through it, and you put it under a microscope and you can identify different minerals in the rocks.
Wow.
And within that, like if there were any metamorphic processes to form this rock, you'd be able to see it on a actual microscopic scale. So I always think of physics. It doesn't mean that I was great at physics. I understand it, but the best. So
you basically got through it, just like with the math. You just got through it. You have to be.
Yeah.
And that's one of the things I want every student says, oh, I got to be a genius in math and I got to know math. I'm like, guys, you just got to get through it. That's all you got.
So that's super interesting that you bring that up. I have this philosophy that math is a tool. Yeah. It's not a subject. So if you could learn just how to use the tool, it becomes a lot easier to understand. And I think that's the best part of being a STEM major, is that you're going to go through those like chemistry, your physics, and your calculus classes. And then sometimes at the same time, you're going to be able to apply that to your other classes. And so you're relearning it over and over again, which makes it a lot easier to understand. And so like I wasn't good at math until maybe senior year of high school. And like once I kind of had that like brain switch, it really helped.
Excellent. Well, questions have been popping up. So Ravino Makadan is asking, what is the most difficult part of your job?
Great question. I think there's two things. I think so remember on those slides where I have a technical role and an advisement role. In the technical side, I think it's just earning all of these years of experience. And with that comes like wisdom and knowledge of different environmental laws. Like we're always talking about the California Code of Regulations, which are state laws. And a lot of all of the hazmat regs are covered by that. And so the hardest part for me technically is getting used to that and understanding that. On the other side, as being an advisor or like a consultant to engineers, is explaining why something is important and why engineers or another client that I have, why the issue that I'm bringing them is important and relevant. So those are the two hardest parts of my job.
All right. Amanda is asking, why did you choose your specific field in geology instead of another one such as seismology?
Great question. It's 100% because of all of the experiences I had in college, all those work experiences. I've always been environmentally inclined, like throughout my whole life. My fourth grade class went a trip to the California Science Center for like reduce, reuse, recycle PSAs. So it's always been a thing for me.
Excellent. Jesus Gomez is asking, if it wasn't for geology, what other career would you have pursued or considered?
So my entire life, I wanted to be an educator. I wanted to be a teacher until about 10th grade, where I realized it wasn't for me. So, but now a few years removed from 10th grade, I would definitely go back into teaching, maybe as a second career much later down the road.
Excellent. We can always use great teachers. Letty Patino is asking, what a wonderful presentation. First of all, thank you. What does a typical day look like on the job? Could you maybe describe some of your daily tasks?
Sure. So right now, my day-to-day looks like planning my attack to assess those 200 acres of the PRB program. So I'm using like a GIS type of app or system, and I am looking at each of these sites. I'm scheduling work for that. I'm delegating those parcels or those sites to my other team members. I'm a project manager, so my day-to-day looks like a lot of delegation, a lot of planning, and things like that.
Excellent. Ronald Encanto is asking, how does your job interact with other jobs outside of your work field?
That's an awesome question. So funny you should ask. My job you could kind of think of me as a client for environmental consultants, for private business environmental consultants, which my husband is an environmental consultant. He actually works private side. So I reach out to these private side consulting firms to do our work. So I'll plan it and then I'll call them and say, I need this scope of work done. So that's how I interact with them. I interact with regulatory agencies by using what are called screening levels, like acceptable concentrations of contaminants in different phases. So that's how I work within the environmental sector. I don't really work with geotech too much, but I do have friends in the industry from college. And so we're always meeting together now that we're all vaccinated and happy. So we're always connected.
Excellent. Mary Lou Quintero is asking, how would you describe your journey as a woman in the engineering fields, or STEM fields, I should say?
Yeah, great question. And I'm sure many young female professionals and high school students and college students have this question right now. I will say I was really fortunate. My mentor in college was a female professor. I had there was actually quite a large number of female students in my cohort in college. And we there wasn't, in my experience, there wasn't a huge difference between my male peers and my female peers. We all got along. We were all respectful, and I had a really awesome time.
Excellent. What is the most valuable lesson your job has taught you? Is coming from Vanessa Patino.
Great question. I think from my first job at that oil gas lab, this might sound surprising, but customer service. It was a customer service forward job. And so that really changed my perspective on how I approach problems. My boss and her boss would always say, okay, that's great, Kim, you've identified the problem, now find the solution. Yeah. And you want to be able to give your client or whomever at least 3 different solutions. You need to be able to think quickly, like, okay, we could go with option 1, option 2, or option 3. That's hands down has been the best thing that has ever happened in my career so far.
Excellent, excellent. She's also asking, how do you fight against people who don't believe in taking care of the environment? And what is something that you tell them to try to change their mind with your knowledge in geology? That's an in-depth question right there.
That's an in-depth question, but I always lean on facts. I always lean on knowledge. It's not my purpose in life to change somebody's mind. I can give them my information, my perspective, but if at the end of the day, they are emotionally attached to their way of thinking, it's not worth my energy to try to convince them otherwise. So while I do present my facts and do present my opinion, I'm not going to change somebody's mind based on one conversation. So.
And Kylie Yang is asking a very specific question. I'm going to expand on it a little bit. With all of the technical presentations that we've had over the course of this year, thank you to Zoom. It's been so much easier to get people to talk. Every single one seems to have a story of the internships that they've gotten in college. So Kylie is asking, was it difficult to search for internships and work experiences in college? I kind of want to expand on a little bit more. Does everybody have an opportunity to get an internship based upon their degree major in college? Because back when I was in college, back a long time ago, we didn't have to get internships in terms of stuff. So now it seems that is like the common thing to have. Is it available for everybody, or is it only for a select few? So I'm going to add to that question.
This is a great question because it reminded me of something that I didn't put in my presentation and want to tell everybody. So internships. So not only my college internship through the port, but the port also offers high school internships. I don't know if they're doing it this summer because of COVID, but if I find out about it, I'll send the information to Mr. Fisher.
Yeah, it was actually canceled earlier. It was about a few weeks ago. They were going to put out the application, then they decided not to. And so it is canceled for this year, but it should be back because Cabrillo's had numerous kids get internships. And
awesome. Yeah, I've been a mentor for 2 of the interns last 2 summers ago, I think. Excellent experience. Highly recommend it to all high school students that are available to do it. Okay, so the question was, are internships available for all majors, or what sort of
well, just how easy was it, like, for all of the people, your peers inside of getting a geology major? Did everybody get an internship, or there were people that were left out? Because everybody's talking about these internships now, especially in the STEM fields, engineering, geology, so on. I'm just curious, as a teacher, like,
sure.
are there enough opportunities for everybody who wants one, or is there a fight to get specific internships?
They're typically very competitive. You could get ahead of the curve by knowing about them before others do. I knew that the Port offered college internships. I don't think a lot of my peers did, and I don't think, honestly, many of them were very interested in doing what I did at the Port and what I do now. There's also other opportunities called Research Experience for Undergrads, REUs. These are, I believe, funded by the National Science Foundation. You could Google any or REUs, and it's a government sponsored program through grants. And so you go anywhere in the country if you get accepted and work on different projects. So I actually, before this presentation, looked it up, and there's like a database that lists different professors, different projects. And so you find specific projects that interest you, and you can apply to work on those projects. And I believe they're paid. Those are highly competitive. I almost applied to one, but I did my Port internship instead. But I would definitely recommend looking further into that. And one of the ways that you could get ahead of the curve on REU is once you're in college, is say you find a project that you want to work on, it'll give the professor's name. You can look up journal articles that they've contributed to or have written their research, read those, and like the professor would be like, wow, he or she actually read my paper. Like, that's more than what candidate number 3 said. So highly recommend that.
Excellent. Well, ladies and gentlemen, are there any other questions that any of you might have? I am going to post up a Google form for you guys to actually, if you can please fill out, to give us a little bit of feedback about this technical presentation. Inside of there, I'm going to share the screen really quick. And so my apologies. Where's my picture? There it is. So this is, I got the wrong one. I clicked on the wrong one. My apologies. We do have one more final technical presentation of the year. They both kind of sprung up on me here pretty quick. And so, and Ms. Dillon, this one might be something in which you might even be interested in watching next week. It is happening next Friday. It is called The Climate Crisis and Its Solutions. Ms. Lisa Swanson, the former environmental director of Matson Navigation, will be the speaker next Friday. She'll be presentation number 9. I typically only get about 4 to 6, so hitting 9, I'm a very happy guy. So she'll be discussing the climate reality project training that she just finished, and the causes of climate change and what we're seeing as a result of that and what can be done about it. So I do hope that all of you join us next week. If you can please fill out the Google form for us today. And so we can give Miss Dillon a little bit of feedback about stuff. And I can see just really, because to me, geology has always been an impactful part of what I wanted to study, as I was first going to be a geology major, then an oceanography, then somehow I slid into math and never gave it up at that point. So, but it is, yeah, it's really cool stuff. So guys, if you can please fill out that Google form, I'd greatly appreciate it.
Definitely take a Geology 101 as an elective or a GE in college. It will fulfill a physical science course, and it's a lot of fun.
And Ms. Dillon, you mentioned a project before you started your presentation that you mentioned that your teacher gave it to you during the presentation of what you did over at Poly about that they would bake cookies and brownies and you would have to dig with certain tools. If you would like to help me develop a project like that for one of my engineering, teach principles of engineering, I would
We
love
also,
to do that.
we also did one where we built a structure out of toothpicks and marshmallows.
Excellent.
And he had like table trampolines, and we had to like mimic a seismic event. And
Excellent.
so it was Mr. Filippo at Long Beach Poly, who also was the cross country coach, and I think he did swim coaching too. I think he just retired though.
Oh, I was going to say, maybe I'll look him up and see if I could talk to him about it.
I would highly encourage it. He was awesome, and he recruited a lot of high school students in my year to go to Long Beach State and become geology majors.
Well, excellent. He did a great job, and thank you so much for your time and energy today. I greatly appreciate it, and so do our students. So I do want to say thank you, ladies and
Thank
gentlemen.
you.
That wraps up our CED technical presentation number 8 from Long Beach Poly.
Woo, woo, go Jackrabbits.
You guys take care. Have a wonderful, wonderful weekend, guys, and we will see you on Monday. Take care.
All right. Thank you, everybody. Bye.
Thank you, Miss Dillon.